Dear ladies and gentlemen, I shall present a project of renovation of City of Ilok Citadel Ramparts. So, defense system of the city of Ilok was built from the 13th century to the 16th century. Over the years, the walls were devastated and so on. Ramparts were partially restored, repaired, and strengthened during the 1960s and 1970s. We joined the project in 2009. Designing was preceded by extensive research work, which included soil mechanics and determination of mechanical properties of the walls. The renovation was carried out in two phases. The first one from 2012 to 2015, and another one, second phase, was just being completed a few months ago. During the renovation, a part of Rampart was collapsed. So, here is plan of the city. You can see that towers were built before the ramparts before them, and that is problem, or in one way and another way we have possibility to easily solve some problems. Total length of ramparts is approximately 1,400 meters. It has 7 towers, 4 semi-towers, bastion, barbican, a manor, and monastery with church. The average height of the walls is 11.1 meters, and the highest is 16 meters. We have these problems on the ramparts. That is, I'm sorry. Back, is it possible to come? No. That is deviation from vertical for 8 to 14 centimeters, different kind of cracks, vertical, diagonal, and so on. Also, in Hammam we have very, very great cracks. Another cracks in the house B, which was restored, and special point on cracks on rampart between semi-tower 6 and tower 7. We have eroded mortar in joints, eroded bricks, caverns in the walls, efflorescence, patching with cement mortar, vegetation, corrosion, reinforcement in reinforced concrete parts. So after we receive the existing state drawings, we start with assessment, and we test mechanical properties of masonry, testing shear strength of masonry on 30 points, that is points on all around. We take, we have very, very poor results of cohesion and of angle of internal friction, but we have no doubt in that, because see mortar like this in these walls on the outer side. So we take 60 samples of bricks and tested it. Also, we try to test it compressive strength of mortar, but it is impossible because mortar is decayed. We try to use the Brazilian test, and we are taking out cores from wall, but they are correct. Before we couldn't test it because they cracked during pulling out. So we have very extensive geotechnical investigation, 10 boreholes with 98 meters long, 46 exploratory pits, a very extensive laboratory research works, and foundation soil is earth, fill, and loess, and there is one tunnel under the city, but we can be sure if it is under the rampart or it doesn't reach rampart. And there are two solutions for the foundation, rehabilitation of foundation. We use this one without micropilots. So we divide structure in 8 parts, individually analyze any tower and individually analyze these ramparts between them, because we have natural or created dilatation between them. So this part, northern part of ramparts, we didn't analyze because it was strengthened before. This is another part, and that is another part of northern. They use reinforced concrete and these empties in the wall to decrease the mass of structure. And we try to analyze 1 meter long wall to be very quick and very easy, but we have problem. We can see that we have problem with soil that is moving everything. So we create 3D models with solid elements and made a static model and pushover analysis. This is part of rampart between Tower 5 and Tower 7. That is the one for which I show cracks, because we shall be back again on this part. So for self-weight, there is no difference between without and with extension. So I will go forward to earthquake. So on model without extension foundation, we can wall can take only 20% of force from the earthquake, and without reinforced concrete foundations extension, we have reached 85% of earthquake force. It means that we increase capacity for more than 4 times. So that is a similar thing, and it is interesting to see that we make dimensions of this extension in such way that we have same ratio of plastification in the wall and in the soil under the foundations. So we have that remediation methods which are known, so I will go forth. And on March 9th, 2023, at 2:55, part of semi-tower 6 and part of the rampart between semi-tower 6 and 7 collapsed. You pay attention of this part in the middle. I'm sorry, I don't know how to come back. This is one rigid block. And it is impossible with the results which we have from our test that's happened. So what's happened? The day before, 2 days before, contractor started to excavation inside the semi-tower 6, and he has a very, very large area without soil, and after 2 days they see that there are cracks appear in the wall, and they stopped work. And what's happened now, we can see excavation area on both sides of the wall. We can see segments of the reinforcement of fundaments, and with dates of concreting, and we can see that it's about some parts were 4 months open under the weathering of, and what isn't okay. And also we can see break zones and this collapsed part. So on this left picture, photo, you see this block. Again, in the middle, you can see this breaking zone, and this is detail of that zone. You can see that we have 2 layers on each face of wall, which have good connection with other parts, and this center part was filled with bricks without or with little mortar or uncontrolled fill of bricks. So in March 2023, I wanted them to explore how deep is that bed part, and what we see. Only a few layers of bricks on the outer side, and the upper side is weak mortar, which is new, and all mortar is very strong. It is lime mortar, original lime mortar, and they use heavy tools to destroy this quality part of wool. So we can go forward. This is sketch of situation in 1967. This is semi-tower 6, and this is photo when they start of reconstruction in 1968. And this is a drawing made by Professor Andrija Mohorovičić in 1967. He made a solution for realized stability of that corner, but unfortunately they didn't follow his project, and they put these anchors for this wall or column reinforced, but that column wasn't constructed. So similar thing on that part from semi-tower 6 to this crack. This crack which make big trouble, and what you can see on the left side in the cycle, you can see a right connection of bricks in the wall and connection with neighbors' walls. We see that gap. We see one side. I know for that picture before, but I can't believe what did they done. And that is a situation in the phase that we make projects. This crack isn't nothing. You can understand that something wrong inside, or I can understand. And what is conclusion of causes? It was simultaneous unfavorable, combination of external influences on the structure and imperfection in the structure, non-compliance with the given project in 1967, insufficiently documented works in 1968, insufficient supervision of the works in 1968, lack of information about imperfections in structure, insufficient structural research methods, long exposure of part of the foundation soil to weathering, more than 4 months, simultaneous excavation along and under the rampart in the length of 4 segments on both sides of the wall. So this is state after the renovation. It seemed more old and better than before. And the conclusion, observing in spirit of guidelines for the analysis, conservation, and the structural restoration of architectural heritage, we can conclude the following. We met the minimal intervention criterion. We did not meet standards for 100% of earthquake force. That is answer of the question for harmonization and safety issues. And the anamnesis was not complete. The diagnostic methods were not sufficient. Although there was an extensive analysis of the structure, it was based on incomplete data on the mechanical properties of the masonry. Although we proposed to the client the installation of equipment for static and dynamic monitoring, that proposal was not accepted. Thank you for attention and patience.